We left off last time on the 7-note away perfect fifth, so that's where we will be picking up this time, noting that this 5 represents the relative position number 5 in the scale we're working on, the Aeolian mode or minor scale. The 7 represents the distance from the first note in that scale, which in our case is the A note, because we're looking at the A minor or the A Aeolian, noting that the perfect fifth has the same interval on the major scale as well as our minor scale on the Ionian mode, in other words, as well as here on the Aeolian mode, and is in most of the modes. So that means that the fifth is one that we're getting a lot of practice with, and that practice is justified because the fifth is going to be in our major chord construction. So notice that although the fifth isn't the note that really defines a chord as major or minor, and therefore you can kind of think of the third as more important in that way than the fifth is one that you can put in there all the time. Almost all the time, right? Because the fifth is going to be there on almost every note that we're going to be looking at in our scale if I want to build a chord thinking of whatever note in the scale as, in essence, our root note, and the fifth and the first would be what we would call a power chord. So we can make a power chord out of basically any modal chord that we're working on from basically any note, except for when we're working from the Ionian, which doesn't have a distance of a 6-note away perfect fifth. Okay, so that's going to be the general idea here. And if I look at it from a chord construction standpoint, we're going to be back here on the fifth. So I don't need to name it something different because it's already an odd one, not an even. So it's the 1, 3, 5. So from a chord construction, it's also the fifth. We're measuring from the bottom, so I'm looking at this as my root note. If I was building a chord, a 1, 3, 5, then of course the fifth would be a major part of that, or I can build a power chord with just looking at the 5, the 1 and the 5, a 2-note chord, if you want to call a 2-note thing a chord. All right, so when we go above it, we have to look for the inverse distance. So I'm going to count that out. And the fault line is going to be from the B to the G. So from the perspective of us, we live on this continent. I'm thinking of this as a fault line. This is one of the tectonic plates here. This is the tectonic plate up top. When I go from top to bottom, I usually think of this plate, this tectonic plate, shifting to the right. But I'm thinking it's easier now that I'm identifying my heuristic down here when I'm on the bottom tectonic plate is to think that when I cross the fault line, it's this continent that moved to the left. That's going to be easier kind of for me to see, which way I should go when I cross the fault line, because there's a kink in the tuning right there. All right, so let's do that. We're going to say I'm looking for the 7-note away perfect fifth. If I go on the same string, 7 notes is kind of a far way to go. I can't reach it as easily. Therefore, I'm going to imagine that I took this string, wrapped it in a circle, which would be like a clock with 12 steps in it. And if I go one side around the circle, it would be 7 steps. That would be the distance of 7. That means that if I go around the other side of the circle, I would only have to go 5 steps to get to the same spot. That's more reachable. So let's do that. So if I was on this A, I can go 1, 2, 3, 4, 5 back. If I went from the E to the A, whoops, that would be a 7-note away perfect fifth. If I went from the E to the A, that would be a 5-note away, which would be a perfect fourth, the inverse. If I go from the A to the E, we could think about that as the inverse, which would be a 7-note away perfect fifth. Let's go above it then. So if I go above it, I'm looking for this E. So if I go above it, I have to look for the inverse distance. So a 7-note away perfect fifth will have an inverse distance of 12 minus 7, which is going to be 5, noting that the inverse of the perfects are each other, which is convenient, yet a little bit confusing. So we have to keep drilling that in our mind, not to get those two mixed up, especially given the fact that a 5-note away distance is not a perfect fifth. That's the perfect fourth. The perfect fifth has a 7-note away distance, okay? So if I'm going above it and I'm looking for a 7-note away fifth, I have to take 12 minus 7 to get the inverse distance, which is 5. So, and that's going to be right above it because I'm not crossing the fault line yet, so I'm right there, right above it. So if I go from here up 1 to 5, top to bottom from E to A, that would be a 5-note away perfect fourth. Therefore, from bottom to top would be a 7-note away perfect fifth. That means if I go up one string, the 7-note away perfect fifth will be right above it unless I cross the fault line, which would only happen on the B string. So if I was on this A, I would then cross the fault line. So the rule is if I go up one string, the 7-note away perfect fifth will be on the same fret unless I cross the fault line. And notice if I'm looking from the perspective of this as the continent of this here shifted to the left. Therefore, from the perspective of me standing still on A, this shifted to the left above me, and therefore I have to have one step back. So if I go up one string, then the 7-note away perfect fifth will be one fret back. All right, let's go up another fret, another string. So we're going to go up here. Now we're crossing the fault line. We didn't cross the fault line here, but we crossed the fault line when we go across these two, looking for the 7-note away perfect fifth. So the inverse distance is 12 minus 7, a distance of 5. If I count that out, we're going to say 5 is the distance between these two strings, and then this continent shifted to the left from my perspective of the A. So to get another 5, I can't go straight up, I'd have to go this way, which would be 10, which I'm going to do even though I'm going away from the note I'm trying to get to, because I don't like to count in 4s, I like to count in 5s as I go up the strings. So I'm going to say that's 10, and then I'm going to call it negative 10, and then I go this way towards the positive, so negative 10, negative 9, 8, 7, 6, 5. Let's do the same lo mismo here. So 5 to here, this continent shifted that way, so 10 would be back here, 10, negative 10, 9, 8, 7, 6, 5, boom. We're looking at that E right there, that's an E. So if I went from this E to the A, that would be a 5-note away perfect fourth. From the A to the E then would be a 7-note away perfect fifth. So if I go up 2 strings and cross the fault line, the 7-note away perfect fifth will be 1, 2, 3, 4 frets, 1, 2, 3, 4 frets forward. But what if I didn't cross the fault line? If I started on the G or the D string, I wouldn't cross the fault line. For example, if I was on this A and I go up 2 strings, then it's going to be out here. Okay, so now, so that means that the normal idea would be if I go up 2 strings, the 7-note away perfect fifth will be 1, 2, 3, 4, 5 frets forward, unless I cross the fault line, which would happen on the bottom 2 strings, 2 out of the 4 times that I could go up 2 strings, right? And then if I go up 2 strings and cross the fault line, then the 7-note away perfect fifth will be 1, 2, 3, 4 frets forward. Why? Because from the perspective of the continent that I'm on, this continent shifted to the left, which made the distance shorter going to it. It moved. I stayed where I'm at. It moved. You're the one that moved. You're the one that moved. I've been here all the time. I've been here the whole time. Okay, don't you tell me I'm moving. You're the one that's moving. And but then they say that anyway. So then let's go up 3 strings. So we're looking for the 7-note away perfect fifth. So we need the inverse distance, 5-note away perfect fourth. So if I go up 1 string, that's a distance of 5. This continent shifted to the left. So this is going to be 10 going this way, and then 15. There's only 12 notes in the musical alphabet, so every time I go above 12, I'm going to bring it back down by saying 15 minus 12. It's going to be negative 3. This way goes more negative, negative 4, negative 5. Let's count it out from here. So we go negative 5. This continent shifted, so it goes negative 10, and then negative 15. 15 minus 12 is negative 3, negative 3, and then 4, 5. So from here, this E to this A, that would be a 5-note away perfect fourth. From the A to the E there, 4 would be a 7-note away perfect fifth. So that means if I go up 3 strings, the 7-note and cross the fault line, the 7-note away perfect fifth will be 1, 2, 3 frets back. I wouldn't cross the fault line if I started from the G string. So if I went from this A up to here, then I would not cross the fault line. So the general rule is if I go up 3 strings, the 7-note away perfect fifth will be 2 frets back unless I cross the fault line. which would happen on the bottom two strings, the B and the E string, in which case if I go up 3 strings and cross the fault line, the 7th note away perfect fifth will be 3 frets back, due to the fact that if I think about this continent being stable, then this one moved to the left, in this case making the distance longer because I'm reaching back, and this continent moved to the left from my perspective. Okay, so then let's go to the next one. And we're going to say we're going to go up here. So we're looking for the 7th note away perfect fifth. Inverse distance is the 12 minus 7, which is 5. So distance of 5. So we got 5 here. This continent moved to the left. So we go 10 diagonal. And then 15, only 12 notes in the musical alphabet. 15 minus 12 is -3, plus another 5 is going to be a -8. When I go this way, I go in the positive direction. I'm on -8 is the way I see it. -8, 7, 6, 5. So let's count it out this way. So I'm going to say -5. This move this way, so -10, -15. 15 minus 12 is -3. -3 plus another 5 is 8. And then I'm going to go 8. And then down to 5, so 8, 7, 6, 5. Boom, boom. So from this E to that A would be a 5 note away perfect fourth from the A to the E. Therefore, it's a 7 note away perfect fifth. That means if I go up 4 strings, I will always cross the fault line because I can't go up 4 strings without crossing the fault line. Therefore, the 7 note away perfect fifth will always be 2 frets forward in that case. And then we can go it up to the top, which is the big distance one. Here's our giant equilateral triangle. 1, 2, 3, 4. Wait a sec, not quite uniform. No, this way is shorter. 1, 2, 3, 4, 5. That makes sense. Okay, so, but I would probably find that more easily because I know these 2 strings have the same notes on it by saying, let me find it on the same string. So if I'm looking for the 7 note away perfect fifth on the same string, I could go up 7, which would be up here, which would be the same on the top string of the guitar. Or I can take the inverse distance. If it's up 7, that means 12 minus 7 would be 5 back. 1, 2, 3, 4, 5 back. And if it's here, it's the same up top. But let's count it up to the top because that'll be fun counting practice. So we're going to say, all right, I'm looking for a 7 note away perfect fifth. The inverse distance is 12 minus 7, which is 5. So if I go up here, it's going to be 5. Then this continent shifted this way, so I have to go here for 10. Then 15. 12 minus 15 is -3, plus another 8 is going to give me, plus another 5 gives me -8. And then plus another 5 gives me 13. The only time we get up to 13 is when we go up 5 strings. 13 minus 12 would be -1, and then -2, 3, 4, 5. Let me try to count it out from here. We're going to go -5, continent shifted this way, so -10, -15. 15 minus 12 is -3. -3 plus 5 is going to be -8, plus another 5 is going to be -13. 13 minus 12 is -1. -1, 2, 3, 4, 5. So if I went from this E to this A, that would be a 5 note away perfect fourth. From the A to the E, therefore, would be a 7 note away perfect fifth. So if I go up 5 strings, I will always cross the fault line because I can't go up 5 strings without crossing the fault line. And the 7 note away perfect fifth will therefore always be 1, 2, 3, 4, 5 frets back. All right, let's do the next one.